Hello, everybody, and welcome to the Before It's Built podcast, a Nezo podcast about people, projects, and materials shaping low carbon construction. For the first episode, I brought on my colleagues, thought it would be a good idea to bring them on board and actually tell you the problems that sit behind Nezo and what we were trying to solve, why we built Nezo, and why decisions need to happen earlier in the design process. As I said, joined by my colleagues, I've got Owen and William here on the call. You guys just want to introduce yourselves and tell us, I guess, your own backstory about how you actually ended up at Nezo and what you do.
Hey, Ron, Will, CTO and co-founder of Nezo. So I worked with Barry and Owen as a quantity surveyor for over 8 years, working on a range of projects from 1 million to 100 million, residential or commercial or even high-end like fit outs. Yeah, I'll pass it on.
Hi, everyone. Yeah, so I'm Owen and COO, so operations at Nezo, which kind of, I suppose, means many hats or jack of all trades. And yes, similar background, so don't need to repeat too much as Will, where although I have a strong emphasis on cost planning in that previous commercial role, which is tied in quite well with what we do now at Nezo, which is to gather insights on projected cost, as well now as carbon and weight outcomes and from the earliest stage of a project so we can make good decisions. And yeah, my role is working with our architect users to understand where they see problems and barriers in that workflow, and then bringing that information back to Will to integrate into the application, into Nezo, to build that tool out. We often talk about how our tool, yes, it's built by Will in Sydney, but it's very much shaped by our users, our architects. So, that's part of that feedback loop. And yeah, apart from that, I have a good, strong understanding of LCA, embodied carbon analysis, different compliance pathways. Again, that's what our users are battling with. And just bring that knowledge base through to the tools.
We've all been working with each other for a couple of years now, and we were all, I guess, kind of moving in the same direction. We were quantity surveyors that were working with software that we weren't entirely happy with, and we started seeing if there was something better out there. Owen, I think the first conversation that we had was actually that you came to me, you were not long in the practice, and you said that you weren't entirely happy with the software that we were using. It was very much a glorified Excel sheet kind of a process. And you said you wanted to actually start thinking a little bit different about quantity surveying and thinking about how you actually measure and anticipate project risk and methodology through a 3D model. You want to give us just a little bit of background on, I guess, where you went from there? Because I know it started with a conversation between you and me where you basically said, look, I'm frustrated.
Yeah, sure thing. We followed quite a long journey and road since then. So I'll try my best to compact this down into a short summary. But ultimately, yes, so change in workflow, change in approach. It was actually derived from detailed carpentry SOQs. So we're talking about large commercial buildings where you do have, because it's detailed carpentry, you're thinking about blocking on steel through to roof framing, internal partitions, trims. So we were required to look at hundreds and hundreds of pages of architectural drawings and hundreds and hundreds of pages of structural drawings and measure each one individually and bring these together and then put them on an SOQ and feel confident that we've captured everything. And to me, that's broken because yes, we created this one single source of truth, which is the SOQ, but we couldn't visually and quickly demonstrate that represented absolutely everything in the drawings. It's too big.
So you went down the route of looking at 3D models, and you kind of self-taught yourself how to use SketchUp.
That was it. So SketchUp seemed like the ideal platform because it's a CAD system, but it's a lot easier and user-friendly. So I was able to jump on that pretty quickly, compared to trying to learn Revit or something similar. Used some extensions, third-party extensions. That allowed me to make it an efficient modeling process. I did want to capture every length of timber, but I didn't want to necessarily draw that. So some tools and extensions allowed me to put some inputs and kind of automate that process. All of a sudden, we had 3D buildings that were very detailed on screen. And we used to joke, just as you mentioned, about how it was always in your head and there's, the single source of information, but nobody else can see it, was that, yes, the bill of quantities or the schedule of quantities was always the BIM model, just in 2D, where we brought the information together. But now we brought the information together in a 3D setting so we could quickly see it. And what we used to say to people was, we always did this, but only we could see it because it was in our mind. We couldn't show someone on screen. We were having 1, 2, 3 hour meetings in 1, 2, 3 minutes because people would look on screen, see an assumption we made around a takeoff. That this is more around cost planning stage when we're making assumptions and go, no, that won't be that way. It will be this way. So we've had a whole conversation just by looking on screen. So we made everything, communication was more efficient, accuracy increased, and the value of what we did was demonstrated better as well. And then I suppose the next step from that was to move on and start going, well, cool, we can build our own extensions. We can look at, something similar to a QS takeoff system and scheduling system and tie that in. And that was when the origin of can we
Yeah.
build software ourselves begun.
Effectively making our workflow as a quantity surveyor closer to what an architect or an engineer were actually expecting, or what they were the way they were working every single day. So we were effectively translating our workflow into a more of a designer's workflow, but extracting the same data and quantification and pricing and all of that from those models.
And I had to convince everyone to jump
Yeah.
on board and learn the new skills. And like you might want to
Yeah.
talk about, that experience where, everybody said at the start, you're like, look, I'd probably just have this done already if I was just back on my 2D takeoff. And I kind of persevered and annoyed everyone. But now, how would you feel about going back? Well,
I don't think I could do it. No. I'm a very visual person as well. So it's like you said, you can just see the issue and solve the problem then and there. Yeah.
Yeah. When you say solving the problem, because I mean, that's one of the key things around this podcast is trying to figure out what the problems are in the industry and actually provide solutions for them. So the problem for you, Will, that you solved within the 3D modeling was effectively you got to see the methodology in 3D and actually examine it and understand how it was all put together, which is a major issue for quantity surveyors in the industry as they come out and graduate, is they don't have the site experience. They've not seen something built. So a 3D model is kind of like the next, progression to help you understand the methodology that sits behind an actual design. So you guys were building 3D models from 2D plans, right? And then what you were doing effectively was using those 3D models to extract quantification. That was the initial step, which solved the methodology perspective, but also made you more efficient in the production and schedules, which again is solving another problem in the industry where schedules are too expensive because they take too long to do. They take too long to produce, and nobody wants to pay for them. So using the 3D model was effectively solving a communication issue for you on and making you more efficient in your workflow. And for you, Will, it was more around a methodology and an extraction of quantification of materials so that you were being more efficient as a quantity surveyor, which was solving the issues for that service.
it also it shifted the approach. So a bill of quantities, often that service for a quantity surveyor will be charged for after detailed design. So we've,
Mm.
gone through a lengthy design period with the design team. The client has spent a lot of money to get there. And, it's ready for pricing in how we tend to, unfortunately, inefficiently tender and procure projects to date. The bill of quantities often gets skipped. What we did was we brought the detailed schedule to the concept stage. So you didn't get your one-page cost plan. You got your detailed schedule then, because as we modeled off the 2D drawings, what we would find is holes, gaps, and problems. That was a byproduct. We'd be able to raise RFIs and find clashes and sometimes critical issues, but we would charge up more upfront for that first phase. So instead of your one page, you got your more detailed document, but then that was just updated and refined through the design phases. So you always had your detailed schedule, which then became a financial decision-making document and actually helped the design process. So as these design discussions would happen during detail developed, you could actually, the client had real-time information to play with and to make decisions. So yeah, you did have to flip on its head a little bit.
Yeah. That's what first changed the perspective of as well around cost, right? So up until now, we'd been using basically cost as a you multiply quantification of materials by the actual price of a material, which it was a bit wider. It embedded the labor, the plant, the materials, the P&G, the overheads, all of that sort of stuff was embedded within those rates. But it changed the perspective around cost, didn't it? Because effectively we moved away from treating it like that to treating it like data and maintaining data and then embedding that data into the 3D model so that the entire thing actually happened within the model itself. That's what allowed you the efficiency of what you were saying earlier on of, instead of having a 2 or 3 hour conversation within meetings, you were able to actually just manipulate those models and actually instantly understand what the cost impacts of different material choices was. And that's what kind of set us off down the road of Nezo, which at the time was called VQuest. But it started us down that road, of treating cost like data and treating quantification of material like data, and then trying to figure out how we could actually work that into a designer's workflow so that we were thinking more like designers and actually leveraging the 3D models. If you guys can remember, how did we end up with the scenario where we were going beyond cost? Will, you were heavily involved in everything that we were doing mass timber. You were pricing for mass timber installers. You were doing work with the suppliers, and then you were also doing work for clients who were wanting to build mass timber buildings. How did we end up basically manipulating models showing the difference between steel and concrete and timber to the next stage of what we were actually evolving into, which was beyond the cost data? Do you remember how that happened?
Yeah, so we were actually breaking down the rates from first principle and working off the installation and the material costs and then bringing it back into the model's geometry. So working up like a beam within a cubic meter. If that beam was a small beam, a medium beam, or a large beam, we could work in the installation, the material costs, the fixings, the connections, the intermediate coatings, all of it into this geometry. So if you could extend the beam or make it larger, those costs, the carbon and the weight would all...
And that's kind of what I'm getting at, is going beyond cost into looking at other metrics. So, we had solidified an internal workflow within our practice to examine cost. But do you remember how we started looking at other metrics like carbon? Was there a key project that we were working on where we were asked to measure carbon?
Yeah, so it was the Clearwater Keys apartments project, which at the time it was the first 5-story mass timber building in New Zealand. So it was one of its kind. And it was a bit of a sample project because no one's done it before. We had a really good team that actually wanted to construct it and produce all the results to the public.
Yeah, open to the market. Yeah, make it open, share all the information and learnings that came out of it. But if you remember, we were partway through that project and somebody just raised the question of, can you guys do more than cost? Because effectively you no longer look like quantity surveyors, you look like data analysts. You're examining the building and you're applying data to it, which was kind of the key moment for us where somebody said, can you go further? Can you do other things? Can you look at carbon emissions associated with material choices as well as the cost impacts? And I think it was around the same time there was some conversations around what other metrics are directly linked to the quantification of material. And what we started looking at was weight. We're examining more today, than just cost, carbon and weight. But it was a key project, right? Because it was one of the first ones that we looked at beyond cost, where we went, right, we've embedded cost into a model. We've examined what it would look like as alternative buildings by manipulating the models. But then we also brought in the carbon and we brought in weight. That was the aha moment. If this data was available while you're designing, there's actually impacts that could be made that are often left on the table unseen, or left under the table unseen. Nobody examines them. So it's that was kind of an aha moment, right? Do you guys remember that?
Yeah. I think just kind of before we mentioned the Clearwater Keys project, you could start to see the dots start to align and form. We were thinking about data rather than just simply cost of concrete. We were thinking about, is there a better way to visualize and produce quantity information? So we started looking at 3D, and we had already started thinking about software development and our own tools. This project, Clearwater Keys, lands, and we had that kind of demand and that ask. And we were heavily involved in that project team. And we had that ask of looking at those other metrics. And Barry mentioned, comparative analysis. So we needed to platform as-built timber model versus concrete and steel versus a hybrid. We were able to use our 3D modeling approach to quickly use the parametrics of model 3D modeling and generate those really quickly. We had to quickly understand the cost. We couldn't go in and develop a full bill of quantities for each option. Everything Will said about how we developed these composite rates that could extract a lot more information from less geometry, so we keep the models light. And that worked. So now we could understand cost versus weight versus embodied carbon. And so everything we were setting ourselves up for, it was beautiful timing. And this project came along and it allowed us to apply all the different facets together in one case study and produce these results. And then what we understood was this wasn't easily replicatable by others. This was unique because of a series of workflows and different tools that we had. We were already starting to build some tools internally in software as well. We thought, I suppose this was the aha point where if we bring this entire workflow together and build out these tools of our own to encompass some of the other parts we're using, well, that's a software product.
Yep, absolutely. And I think when we first started down that road, we thought, we were going to be building a quantity surveyor's tool, something that allowed a quantity surveyor to work in almost in 3 dimensions, but with 3 dimensions of data as well, so that they could see the impacts, not just on cost, but the impacts on alternative parts of the building. Because we were getting questions continually, or when we were pricing those mass timber buildings, we were being told at concept design and preliminary design, make sure that you allow for a reduced foundation demand. But you then ask the question, what does that mean? And you weren't able to really get a solid answer, so that it became unpriceable. I think that's one of the big issues in the industry, is that we're not using data. We're not using wider data. So we're making decisions that are blinkered. In the design process, you've got an architect who's designing a building and trying to make that building aesthetically pleasing, but also perform from, so many different compliance pathways, whether it's thermal performance or whether it's, it's structural integrity or, lighting. There's so many different compliance metrics that they're trying to build to, but they're building it in isolation to the cost performance, the weight performance, the carbon emission performance. The industry as it stands at the moment, and this is where we see the biggest problem, is that the likes of carbon emission and weight analysis and cost analysis, it's all retrospective. That information comes too late because it's too hard to do. You need a specialist to look at it. And by the time you get to the point where you've actually got that data, you've already made all the key decisions, because you need that detail in order to do the analysis. So it's like a chicken and egg scenario of, if we had that information so much sooner, we'd be able to make better decisions. But we need more detailed drawings and more detailed information in order for them to be able to do a retrospective analysis. So it was one of the key things that we were trying to solve at Nezo. And we used that 3D work environment and that 3D workflow of using models from architects and engineers to actually embed data far earlier. You're given a 2D plan, a concept design. How are you leveraging data to actually get better decisions?
I mean, there's a few examples. We could continue the conversation around the core structure and what kind of outcomes can be derived earlier, so like Clearwater, for example, we often hear terms when people are comparing different materials and methodologies that, we'll hear, this product is cost effective. But what does that mean? Nobody's going to make a decision just on advice of this is cost effective or it's faster to work with. Using our tools and approach, we were able to understand quite early in the piece that we were achieving quite a large time saving in construction, which is something that's usually not captured. So I will, you might want to actually mention some of the metrics on Clearwater Keys, for an example, around the installation time of a floor versus what we traditionally would have been doing, and what that meant in terms of time saving on P&G, overhead, craneage, information that usually what we weren't privy to or wouldn't have been able to understand. So bear in mind, a cube of engineered wood is, up to 10 times the cost of a cube of concrete. But, there was a bigger picture there to look at holistically.
Yeah. So we were putting down 350 square meters of CLT flooring in about 4 to 6 hours. And if you were to compare that to concrete, yes, the concrete material is cheaper, but you've got all the propping. You've also got all the scaffolding that needs to be up for at least a month. And by the time we were putting up the next floor, and we didn't need as much propping, we didn't need as many people.
So look, guys, I guess the summary of that conversation is effectively that we're working in an industry that's not really leveraging data, and we figured out how we could leverage data into a 3D model and actually manipulate the model to get better outcomes by selecting alternative materials, running an analysis and seeing what the impacts were. We moved from an in-house solution to trying to solve that problem for architects and engineers. And we did that by effectively creating a connection between their design software and our methodology, right? The problem that we were solving was making it easy, because the data is out there. But it's actually creating the database, making it usable, and then being able to build it directly into the designer's workflow. Will, you were heavily involved in actually creating the application that actually transitioned that. So moved it from just a methodology that we were running in-house into something that an architect and engineer could use. Have you guys had feedback from users now that are using the software on, does that solve the problem? Have we actually made it easy for them to use data?
I think 100%. And it's all about experimenting what you have within your 3D model and experimenting with different kind of materials and the data behind that. So you can quickly analyze and compare different materials within a few different selections.
Yeah.
And I think, talking to the users on their journey, it's just implementing the tool within their practices. I hear firsthand about its intuitiveness, how people can hit the ground running and use this tool. So Will just mentions, they're straight in playing around and experimenting, on day one. They're running results on day one, compliance level reporting. So there was traditionally, with anything related to building science, to life cycle analysis of construction buildings. We just had Excel on a web app. We had series of drop downs, pretty rigid, a lot of terminology people didn't understand. We built an architect's first tool. And that's what Will's created, something that is intuitive, something that, syncs and aligns directly to someone's existing workflow. It doesn't force them to change what they do, how they do it, and what their roles and responsibilities are to use it. There doesn't need to be a specific champion, the one person who's done the 500 hours training, who's now a liability because if they leave, everyone's left in the lurch. It means everybody in the office can pick it up because we've used a format that works for everyone today. And that's really one of the primary feedbacks that we get is that it's easy to use.
I think that was solving a major problem that existed in that there are softwares that are out there for looking at carbon LCA emission reduction and things like that. But they were so complicated that effectively you had to have that specialist, right? So it instantly bottlenecks and almost makes it a validation tool again rather than an insight tool. So it was trying to unblock that bottle and allow data to be used by everybody. And I think we're seeing with our users, as you said, on they're picking it up within the first couple of hours and they're actually doing full building analysis by the end of the day. So I think we've successfully unblocked that. Was there anything that you guys felt that we just got completely wrong? Was there any data, any approach that we took, anything that was just like, oh, we completely messed that up?
Yeah, yeah, nothing detrimental, thankfully. The very first version we had was built to a workflow that we understood. We had to go with something to the architects and then get them to start testing and trialing and being part of early adopter programs and beta testing phases. And we've been very successful at building what works for them very quickly. But at the start, what we understood was our workflow in SketchUp, as opposed to, being, as well versed as we are today in Revit and ArchiCAD. And what we liked in SketchUp was bringing in materials into the model, actually applying them to the model. And then when you sync, Nezo was able to read the model, read the material decisions you've made, and instantly give you cost, carbon, weight, feedback, and metrics. So that required you open up the application. You could go to our materials library. We're not really talking about in this podcast, but that's really powerful. It's not just products, it's full building systems. You import them and you apply them. And we kept that. We rolled it out into Revit, into ArchiCAD, and we kind of had a hybrid workflow where you could map, which we're like, oh, why map? You can just build with these materials. That did not fit with our users' workflow. Immense pushback. And luckily, we always had the hybrid system, and we've been slowly phasing out the import materials, and actually we've tripled down on the capability and the power of how our users can map materials. So use their own naming conventions, their own styles, how they render is not affected then. Import into Nezo and then work on this mapping process. And we've put that on steroids. So it's much more powerful. But we did tell people the best way to work was to import materials and apply them to their models for a very long time. And 99.9% of people did not like that workflow.
Creating a system that's flexible enough that anybody can use it within their workflow is the key thing, that we kind of learned from that process. The next question, I'm kind of a little bit afraid of the answer, but was it harder than you thought it was going to be when we set off on this journey?
100%.
Well, you've massively upskilled your skill sets. Like you became a neighbours assessor, you came from a hobbyist coder right through to somebody who's technically proficient and able to deliver. That's monumental for us. You're able to deliver it and it seems like just effortless for you. So I mean, we've all had to upskill and it's definitely been harder, but it's been a cool journey, right?
It has been, yeah, 100%. It's been challenging at times, definitely, working at all those late nights, early hours, but it's great to see where we are today and the users that we have on board. And every single time we demo to them, they go, wow. They go, how did you build this? And just because of all the times that we've tested, trial with the users.
You're a different beast now, as in like you started off as a qualified quantity surveyor. You're now a CTO. You can code, you can build software. There's not very many of those out there.
No, I wouldn't say so, but it's quite interesting because, coming from a cost background, I feel like cost is our language. So jumping from cost to coding, it's a bit of a leap, but it's not that different.
Yeah. But you had a lot of help along the way as well. It's not to say that you were chucked in at the deep end and told swim. And, we did have an expert as well in that area help us out along the way. So we ended up with something that was well structured and well put together. But on it, the ground that we've made in the last 12 months has been exceptional. I think that we get that feedback as well from our users and from people who saw the software, 24 months ago or 12 months ago while it was still early days. Just a huge movement. And a lot of that comes down to you two guys on with your ability to pull it all together from all the different directions, all the different inputs, understanding what the actual customer and user needs, and then you making the magic happen and making it actually appear. It blows me away every Monday that we come in. You've been working over the weekend and you've found some amazing, solution to a problem that we'd only discovered 1 week earlier. It's just the pace with the way it's moving. You guys are just solving massive problems. Like a good example of that is yesterday evening when I got home, there was a message on chat that basically was, we've just rebuilt QS software as well as doing all of the architectural stuff we've done. So that software that we were frustrated with years ago, you come up with your own better version of it now already, just as a side project, as a side quest.
Yeah, definitely. And it's crazy that, some people are still using a 25-year-old software that hasn't really been updated. So it's great to bring more of the 3D element and the costing element together.
So over the next couple of months, we'll be looking at maybe figuring out ways that we can build QSs into the ecosystem as well by giving them a tool that's better than anything on the market for quantity surveyors. That'd be quite cool as well. But again, those are that's the breakneck speed that you guys are moving at, just continually innovating and continually making the application better. We didn't touch on it, Will, but you were also a neighbours assessor, right?
Yeah, correct. Yep.
Yeah.
So,
and you've been getting heavily into energy modeling. So while we came from QS backgrounds, there is a whole new skill set that's come into what we do and an understanding that actually brings us closer to what users are actually experiencing. How did you find that neighbours assessment role?
Yeah, well, it's definitely, it was quite different from quantity surveying, but understanding the materials and even the spreadsheet, the neighbours embodied carbon spreadsheet, if you've ever seen that, it's one hell of a spreadsheet built by scientists. But yeah, now it's making waves throughout Australia. It seems to be rolling out for lots of commercial and industrial buildings. And it's going to be a key point for measuring embodied carbon throughout Australia over the next few years.
So having that insight in-house within Nezo very quickly got us up to speed with what the actual usage of that tool is, the report formats, and how to actually integrate so the outputs naturally came out of Nezo in a way and in a format that can be used, automating neighbours. The Green Star is the same. And on at the moment, you're upskilling on energy modelling.
Yeah. I suppose I can start that with the same comment as well, in that built by scientists. So again, I suppose everything we present, our unique way of building tools is that we're from construction. We weren't software developers by trade originally. Building scientists by trade originally. So we go and from just our normal construction backgrounds, go and learn these new tools and things like energy modeling. There's a lot of science too, but ultimately a lot of it comes down to materiality and construction systems and just how you manage data. And we already put the data hat on, realizing that's what we were doing with cost. We break it down. We simplify it, we make it more comprehensive, but not harder to use, and we rebuild it back up and we package it for people that are just like us. And that's what you receive on the other end, is something that's easy to use because we went and figured it out. And that's what we're doing with energy modeling next.
Yeah, just making it user-friendly and making it a capability for anybody, not just an expert. So can we see some interesting things over the next couple of weeks, months on Nezo? Our users might see something that we can start marketing out there and showing some game-changing stuff. I know you guys have been showing at recent demos some of the AI functionality. Can you explain what that is? Because a lot of people have have reservations about using AI. How have you guys actually embedded AI into Nezo so that it is trustworthy, usable, but also impactful?
Yeah, I think there's this concept of AI at this point where it can do anything and everything. But the biggest leverage we have is the data. So plugging in the data to the AI, that's what makes this new tool coming out just really efficient.
Yeah, and just to add where we've been very careful about where we position it, in that, we've worked very hard to create a tool that sits into an existing workflow. And we just want to let architects do what they do best and design the buildings. But where we've identified laborious tasks that are just tasks for the sake of, finishing that analysis, comparative analysis, for example, nobody wants to have to go and remodel an entire second building. And yes, you can use the efficiencies and the automations that the Nezo tool gives you and the power of your CAD system, but ultimately it still might potentially take you hours to produce something comprehensive enough to say this is option A versus option B. Well, why don't we focus on letting the AI help you create that option B faster? Your design that you're working on is still yours, but the AI has helped you create those benchmarks and potentially highlight some good ideas. If you like them, you adopt them, and then you go back to your own workflow and you implement them. So it augments your workflow and it helps out where time is going to cost and you might not necessarily have that time.
Yeah, that's the key thing. Time barrier, removing that time barrier for architects. Because that's the key thing that's, I think, holding back the entire industry is how long it takes to do these things. There's no guaranteed outcomes either from these activities. So having something short circuit that, not do the work for you, not design the building for you, but provide enough insight that you can actually then make a decision as to whether it's worthwhile to investigate it, adopt it, and design it.
I think, as you always say, that the architects create the art and the AI can do the dishes.
Yeah, pretty much. What do you see changing in the industry? Not, and I don't mean from a Nezo perspective or even from a legislative perspective, which we all know the legislation will eventually arrive here. But in New Zealand, it's already rolling out in New South Wales. The NCC across Australia is also talking about adopting carbon measurement, carbon reporting, and carbon reductions as well, which will make it Australia wide. But what do you see material wise? Do you see anything interesting coming? Is there any material that you guys see is creating a huge impact right now, or can create a huge impact right now in the decisions that are being made?
Yeah, I think concrete has always been a huge focus, and steel, of course, high carbon emitters. And, historically, a lot of science behind those materials. So, there's probably concrete, for example, there's two kind of fronts. There's one with the kind of traditional global suppliers, the manufacturers of cement, looking at how they can reduce carbon emissions associated with those concrete mix products. And we're already seeing kind of as default, 5-10% reductions in upfront and body carbon associated with those products, and that will gradually decline. So there's that front, which is more mainstream. You're seeing a slower decline as new technology in how it's produced comes together. But then on the other side, in like the startup world, right around the world, we're seeing kind of what appears from the outside like silver bullet type materials, where they are finding a new way to produce cement that when you use it in concrete, to produce concrete, you're seeing, we've heard numbers up to 90% reduction in embodied carbon. So a lot of that is still R&D phase, but there are businesses and companies established that are working on those. Of course, in steel, then with, electrical arc furnaces and the like, and we're seeing kind of this green steel come online. And there's a lot of work being done around circularity and trying to understand some materials are more recyclable than others and can come back around, and just giving that metric and incorporating that metric into our understanding when we report emissions, end of life, things like that as well.
You're based in Australia. Do you have a different perspective or do you see different things happening over there? From a material perspective, is there anything that jumps out at you? I know that last week we spoke about bamboo. I know that Saveboard, who are doing the circular plasterboard and bracing element alternatives. Do you see anything else over there? Is there anything else jumping out?
I think Owen did touch on the green steel, and I think that's going to be a big leverage over here. A lot of the big steel manufacturers, it's kind of going to be a bit of a race to who can be the lowest carbon steel, because they'll definitely start winning more and more of those projects as consent comes into
the demand starts coming along for compliance and natural thresholds that we need to start meeting.
We just need to start reducing the amount of coal we use to generate that electricity.
Yeah, 100%. Yeah. Cleaning up the grid as well as the actual material circularity and even the reuse, not necessarily the reusing waste, but actually reusing the products themselves. So having a second use for a building or, a frame of a building, understanding how that can be dismantled and reused again. All part of that circularity and making things last longer as well as another critical thing. I think we've ended up in a world where we've gotten used to throwing things away. Well, how can we make things better that last for longer?
I think something that represents that comment and sentiment really well is the new emphasis from Green Building Council Australia and NZGBC regarding fit outs. So we always thought about, embodied carbon emissions of creating a new building, say an office building, for example, and understanding to make sure it's efficient. So our operational carbon emissions, our operational energy usage, and making sure it's an efficient building. But what was kind of disregarded was the fact that, every 7 years, 8 years, an entire portion of that office block could be completely gutted and refitted out. We're talking from steel partitioning through carpet finishes and the like. And that wasn't really acknowledged, recorded. And, with the Green Star fit outs now, we are starting to think about that waste of material. And, if you we're not going to do anything about it if we don't start measuring it. So that, again, that's where the start of that road, where we'll start to measure it and people will start to understand the impact, and then they'll be able to benchmark against that to start looking at how do we do better? How do we reduce that going forward? So, that's something that is kind of new.
That's awesome, Mon. We more or less wrap it up at that, I think. Just one last parting question. If you were talking to an architect or an engineer tomorrow, where would you tell them to start? What's the first thing they should do?
The sign up page.
The Nezo sign up page, is it? Yeah, nice. Yeah, I think just literacy and understand what's coming.
Yeah. And look,
Just
we have free resources. There is a section on our website that explains, neighbours emissions reporting under SEP legislation in New South Wales, as well as basics, those pathways, what's required of you when it's required. Then our app provides a free set of features, including our products inspector that allows you to go and visit materials and see more and learn more about them without necessarily having to live inside a neighbour spreadsheet. And, get exposed to how accessible the likes of Nezo can make information to you. And then as more gets asked from your clients, you'll have some resources on hand.
Yeah. So that product inspector is like a quick reference on anybody can go on there and access it and just see how different materials perform.
That's it. Traditionally, you might have to know what product you need, go find an online resource for a PDF document, and then sift through 152 pages trying to find the data that you need, which is probably going to be in kgs of CO2 emissions, and try to work that, well, what's that in a cube or a lineal meter? We've done all that for you. So we've made it nice and digestible and all in one place. So you can quickly search, find what you need, understand the products, the emission factors, and actually compare against other products and quickly get an understanding of, is there different specifications or materiality you can make to make improvements. And that's just a nice, simple way to get started.
What I'll do is afterwards, I'll stick up the website so anybody can actually just follow that through and find the information. You'll find out more information about Nezo there as well. That is the podcast Before It's Built. If you are an architect that's got great outcomes on your projects, or you're in the process of making change to the way your practice rolls out carbon measurement, or you've got a sustainability action plan that you want to speak about, or you're a material supplier that is supplying something fairly unique to the market, something innovative and something that is either circular or reduced carbon emission impacts, we want to hear from you, have you on the podcast, and yeah, you'll get to do one of these. So thank you guys. I appreciate your time today and enjoy the rest of it.
See you later.
Bye, everyone.